Hi everybody. Now let us discuss shear stress in I section, one of the important sections in beam. So how the shear stress varies through the height, that's what we are going to now discuss. Since we have flange and web, this is web and this is flange, we cannot directly get shear stress. We have to first consider flange. So first we will consider flange and then web. This is web. So the general shear stress equation, we know the V is shear force, Q is first moment of area, and B width, and I moment of inertia of area of the section, particular section. Now we are considering only the flange. So the width here is B. So for that we take a small area, and for this area let this be the centroid point, and that distance from neutral axis is y bar, and the area, it is y distance from neutral axis. So now we need to find Q. What is Q? A y bar. So what is area? B into this distance. So h by 2 minus y. B into h by 2 minus y. Y bar. So half of this distance, y plus half of this distance. What is that? H by 2 minus y, half of that. So half into h by 2 minus y. So y bar is y plus h by 4 minus y by 2. So this becomes h by 4 plus y by 2. Now ay bar, B into h by 2 minus y, h by 4 plus y by 2. Multiplying this, B into h square by 8 plus hy by 4 minus hy by 4 minus y square by 2. Okay, this goes. So now the shear stress V by B, I, this B into h square by 8 minus y square by 2. If you take this 2 out, we will get V, this BB goes, V by 2I into h square by 4 minus y square. So for flange, V by 2I, h square by 4 minus y square. So at y equal to h by 2, h square by 4 equal to 0 at y equal to, now at y equal to h by 2 we are here. Now we want to get shear stress here. So here the height is h by 2. So h by 2 equal to v by 2i h square by 4 minus h square by 4. So to v by 8i h square minus h square. This is the general expression for the shear stress variation for the flange. Now we got to get the stress distribution here. If we start directly from here the same way, leaving this, then we will get shear stress 0 here. So the shear stress will not be 0 here. So we need to consider a cross section, an area here, y distance okay. So the area is this. So now we need to find, let us take this as 1 and 2, then we need to find, for 1 the centroid point is here, for 2 the centroid point is here. We need to find the y bar value. So y bar equal to a1 y1 bar plus a2 y2 bar by a1 plus a2. So a1 plus a2 is nothing but the total area. So a y bar equal to a1 y1 bar plus a2 y2 bar. So what is a1? So this is 1. So a1 b into h by 2 minus h by 2. So y1 bar is here, y1 bar. So h by 2 plus this distance. What is this distance? Half of h by 2 minus h by 2. So h by 2 plus h by 4 minus h by 4. So y1 bar equal to h by 4 plus h by 4. So a2, so let this be b, okay, and h by 2 minus y is this distance into b. So b into h by 2 minus y, y2 bar So y plus half of this distance, half of h by 2 minus y. So y plus h by 4 minus y by 2. H by 4 plus y by 2. So now we are going to substitute in our shear stress formula. Okay, so before that, let us do a y bar. So a1 b into h by 2 minus h by 2 y bar, h by 4 plus h by 4 plus b into h by 2 minus y, h by 4 plus y by 2. Okay, take this 2 out, this 4 out, b by 8, h minus h, h plus h, this 2 out, 4 out, b by 8, 2 out, so h minus 2y here, h plus 2y. So now we can substitute this in shear stress formula. So shear stress equal to V a y bar by small b I. So a y bar we will substitute. So v by b into I into b by 8 h square minus h square plus b by 8 h square minus 4y square. Okay, so we'll take this 8 out, bring b inside, so v by 8i, b by small b, h square minus h square plus h square minus 4y square. Okay, so W web, shear stress web at y equal to h by 2, what will happen? H square by 4, so this term will go, so v by 8i, capital B by small b, h square minus h square at y equal to 0, get V by 8I. This will go to 0. And we'll get V by B into H square minus H square plus H square. Okay. Now this is at H by 2. So flange at H y equal to H by 2, what did we get? V by 8I into H square minus H square. This is what we got. Now compare this at H by 2. Okay. If you compare this, V by 8I, okay, into H square minus H square, V by B. So this becomes, therefore, W equal to B by B of the flange. So at junction, now we are going to draw the shear stress distribution, and at y equal to 0, this becomes maximum. So this W could be written as maximum. So we had at y equal to capital H by 2, there is one stress value which is 0, and then we have at H by 2 flange value, and at H by 2 web value, and maximum is happening at y equal to 0, that is neutral axis. Now how do we draw the shear force, shear stress distribution? Just project this. So at y equal to 0, H by 2, capital H by 2, we got shear stress equal to 0. So it is 0 here. At y equal to H by 2, we got tau flange value. So, and that value is V by 8I. Let me write H square minus H square. So its parabolic variation will get, right? We are here. Now at web, again, at y equal to H by 2, web, this is flange, we equal to B by B of flange. So we are here, and at y equal to 0, that is neutral axis, the stress value is still higher or it reaches the maximum. So at y equal to 0, tau equal to tau max. So if you see, this variation is also parabolic, so it will vary like this. This is the shear stress distribution or variation for I section. Is this clear? Thank you.